Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the fourth lecture of chemistry first year. The chapter name is Thermochemistry. The topic name is Thermochemistry and Energy in the Chemical Reactions. First of all, what is thermochemistry? Thermochemistry is the part of thermodynamics which deals with the study, measurement and calculations of thermal energy changes occurring during chemical reactions. It involves temperature changes. As you know that temperature decrease, the rate of reaction decrease, and when the temperature increase, thermal energy changes occur in the chemical reaction and reactant converts to product. So thermochemistry is the study of the energy and heat associated with chemical reactions or physical transformations. It means one chemical or one substance change into another by reacting it with some substance or catalyst. A reaction may release or absorb energy and a phase change may do the same, such as in melting and boiling. For example, liquid may change into the solid. This is a phase change. Or solid may change into a gas. Liquid may change into a gas. This is a phase change. Also, temperature changes occur during a chemical reaction and one substance converts to another. SI unit of thermal energy is joule. As you know, the unit of energy is joule. So, the unit of thermal energy is also joule. But when the energy changes during a chemical reaction are large. It means that we have to provide more temperature, more energy changes occur in the chemical reaction. So we will express the thermal energy in kilojoules, kJ. Thermodynamic is branch of science which deals with the study of transformation of thermal energy that takes place in physical or chemical processes. Now, what is origin of heat of reaction? In a chemical reaction, the amount of heat that must be added or removed in order to keep all of the substances present at the same temperature. The amount of heat added or removed, it means that energy will absorb or release. When energy will absorb, it means the reaction is endothermic reaction. And when the energy or heat will release or removed or escape, then it will be exothermic reaction. Some reactions will release energy and some reactions will absorb energy, and the energy will work here is heat. Whenever a chemical reaction will occur, it will release heat or will absorb heat. When it will release heat, the reaction will be exothermic, and when it will absorb, the reaction will be endothermic. This is a general flow chart of the heat of reactions. In a reaction, the heat may be added or removed. When heat is removed, it means the heat gets released and the reaction will be negative. Del H will be negative and the reaction will be exothermic. When heat will be added, the reaction will be endothermic and del H will be positive. You can see clearly the cases here. When heat is absorbed, the reactants react with heat. Means heat is added to the reactants and product is formed. It means the value of del H will be positive. And in case of heat released, the reactant form product plus release of heat. It means that del H will be negative. Some of the examples are burning of natural gas, that is methane, dissolution of sodium hydroxide in water, and neutralization of acid and base produce heat. While heat is absorbed during evaporation of liquids, melting of ice, dissolving of ammonium chloride in water, and cracking of alkanes, etc. In all these processes, that is in evaporation of liquids, melting of ice, dissolving of ammonium chloride in water. In all these reactions, heat will absorb, the reaction will be endothermic and del H will be positive. The first type in chemical reaction is called as exothermic. So an exothermic reaction gives out energy or heat to the surrounding and the system loses energy. The heat will go to the surrounding, and the system, it means that inside the energy will be lost and the reaction will be exothermic. In exothermic reaction, many reactions release energy in the form of heat, light, or sound. These are exothermic reactions. In a chemical reaction, the amount of energy required to break the old bonds of the reactant is lower than amount of heat released for formation of new bonds of the products, and thereby heat is transferred from system to the surrounding is referred to as exothermic reaction. For example, in the burning of methane gas, the bonds between methane and oxygen are broken, and the new bonds are formed between hydrogen and oxygen to make water, and between carbon and oxygen to make carbon dioxide. It means methane reacts with oxygen to form carbon dioxide and water. This is the exothermic reaction because heat is released into the surrounding and lost from the system. So the del H will be negative and its value is minus 890.3 kilojoule. As we know that thermal energy changes are larger, so we will represent it with kilojoule. Here you can see that the energy required to break the old bonds of reactant molecule is less than the energy released for formation of new bonds of the product molecules. So the heat is transferring from system to the surrounding. This is a general graph of the exothermic reaction. The reactants are converting into the products. The reactants need less energy. It means that for the breaking of bond less energy is needed, and for the formation of new bonds more energy is needed. So del H is released, del H is negative, heat is released, and the reaction is exothermic reaction. Now endothermic reaction. An endothermic process takes in energy from surrounding and the system gains energy. The heat is absorbed from the surrounding and the system will gain it and the heat will absorb. Here the change in enthalpy del H is given positive sign. So an endothermic reaction is any chemical reaction that absorbs heat from its environment. In a chemical reaction, the amount of energy required to break the old bonds of the reactant is higher than amount of energy released for formation of new bonds. Here the products need less energy for the formation of new bonds and the reactants need more energy for the breaking of the old bonds, and thereby heat is penetrated from surrounding to the system is referred to as endothermic reaction. In exothermic reaction, heat is transferred from system to surrounding, and in endothermic reaction, heat is transferred from surrounding to the system. In this way, heat will absorb and del H will be positive and the reaction will be endothermic. Here's a general layout of the endothermic reaction. The energy required to break the old bonds of the reactant molecules is greater as compared to the energy released for the formation of new bonds of the product molecule. So the heat is transferring from surrounding to the system. Here you can see that in the exothermic reaction, the reactant is converted to product and the reactants needs less energy to convert into product, while in endothermic reaction, the reactants bonds are stronger and need more energy to form the products. Now, what is heat of formation? The heat of formation of a compound may be defined as the quality of heat change during the formation of 1 mole of a substance from this constituent element. The example of endothermic and exothermic reactions are when hydrogen reacts with iodine to form hydrogen iodide. This is an example of endothermic reaction. The nitrogen reacts with hydrogen to form ammonia. This is an example of exothermic reaction. Sulfur reacts with oxygen to form sulfur dioxide. This is also an example of exothermic reaction. Carbon reacts with oxygen to form carbon dioxide. It means that the heat is released, and this is also exothermic reaction. So this is a general concept about thermochemistry, exothermic and endothermic reactions. I have told you all of these. Heat of combustion, that when methane gas burn, it reacts with oxygen to form carbon dioxide and water. Thank you so much.